Another operation that you can do with matrices is multiplication. Multiplication of matrices is a little bit different than addition. With addition, you had to have two matrices that had the exact same dimensions. With multiplication of matrices, you don't necessarily have to. What this means is if you have a row by column, and then you'd multiply it by a row by column. With this, these two numbers here have to be the same. If they're not the same number, then you won't get an answer. These numbers on the outside, they give you the final dimensions. Okay, so that looks a little bit confusing, but it'll be easier when we actually have numbers there. Okay, so with that, let's say that I have 1, 0, -1, 2, 3, -1 times 4, 2, 2. All right, so the first thing that I always do is I write down my dimensions. So A, I can figure out if this is even possible, and B, I can figure out my final dimensions. So looking at this first one, remember it's rows by columns. So this one here is a 2 by 3, and this one over here is a 3 by 1. So this tells me that my final dimensions are going to be a 2 by 1. So this is going to be in the form of this and then this. Okay, so that kind of helps me figure out where things go. And I'm just going to erase this for right now, just that right side, so we can figure out and set up our pattern. When we're dealing with our this top number, this is technically row 1 by column 1. So what this means is you take row 1 times column 1 of the second matrix. So row 1 of your first matrix and column 1 of your second matrix. Okay, so I'm just going to erase this here. So with my multiplication, I'm taking the yellow times the yellow. Well, how does this work? We've got lots of numbers. You multiply the top number, or your first row number, times your first column number. So 1 times 4. Then you add your second row number times your second column number. Then you just keep going down that line until you're done. So this would be all of my answer once I add it together. So now I'm going to do the other one. I have row 2 times column 1. So I have 2 times 4 plus 3 times 2 plus -1 times 2. So something to notice here. If you notice in my matrix on the right, all of the outside numbers, so the 1, 0, -1, I always stick those as my outside numbers with my row. Inside the parentheses are my column numbers. So if you look at this, you can see that this right here is the 4 and 4, 2 and 2, 2 and 2. Those match up with the column, where the outside number on the outside of the parentheses matches up with the row. And I always set it up that way in that type of pattern, so it's easier to solve. So now I'm actually going to simplify this to get my final answer, because you aren't just going to leave it there. So you're going to have 4 plus 0 plus -2. That's going to give you a +2. On the bottom, we'd have 8 plus 6 gives us 14, minus 2 gives us 12. So our final answer is 2 by 12, is a 2 comma 12. So we'll do another one of these. We'll make it a little bit more challenging. Notice I'm also making this a little bit smaller so I've got more room. So we've got a 2 by 2, and we're going to go with a 2 by 3. So right now, I know my final dimensions are going to give me a 2 by 3. Which is in this form. All right, so I'm going to leave that up there, and I'm going to do the work down below. So on that first one, this first element position, this position here, is row 1, column 1. So row 1 times column 1. All right, so realistically, and like I said, I'm doing the work down below. So I've got 1 times 1 plus 0 times negative 3. So again, I'm leaving my row numbers on the outside of my parentheses, and inside my parentheses are going to be my columns. So now if I move on to the next one, this spot, that's still row 1, but this time it's column 2. So I've got 1 times 0 plus 0 times negative 2. Keep going on in this fashion. This is still row 1, which I canceled out my numbers so you can't see them. Sorry, I'll erase that after I get done here. So I've got 1 times 4 plus 0 times 1. All right, so I've completed now the top row, and I'm just going to keep going with that same fashion, but now for the bottom part. So I've got negative 1 times 1 plus 0, not 0, sorry, plus 3 times negative 3. Negative 1 times 0 plus 3 times negative 2. So by this point, I've set up the pattern. I don't even need to look at my matrices anymore because I already know what the outside number is going to be. The outside number is going to be the negative 1 and that 3. And I just need to transfer down my parentheses. Okay, so now I need to actually just simplify this and put it into my matrix. So 1 times 1 plus 0 times negative 3 is going to give me, so in this top left entry element, I've got 1. 1 times 0 gives me 0, plus 0 times negative 2 gives me that 0. Then I've got 1 times 4 plus 0 times 1 gives me a 4. On the bottom left, I've got negative 1 plus negative 9 to give me negative 10. In the middle there, I've got 0 plus negative 6. And in the bottom right, my only one left, I've got negative 4 plus 3 gives me that negative 1. So this is matrix multiplication. Again, your dimensions do matter. They don't have to be the exact same, but you need to look at the middle numbers and make sure you write out what your matrices are in terms of dimensions. It'll also give you a benefit of the doubt when you're trying to figure out what the final matrix size will be. It kind of helps out.